Okay, so now we're going to walk through our code with a tool I like to call PythonTutor. Anytime you're practicing interview questions, I recommend that you go through and walk through your code with PythonTutor because it will help you during the review process. When you're on a whiteboard, what you'll need to do is be able to walk through your code step by step and see what the interpreter is seeing. PythonTutor can really help with that because it visualizes it for you. So let's take a look at our code and see if it's doing what we expect it to do when we expect it to do it. Okay, so this is our code that we wrote earlier in the last video. What Python will do is create those two functions, store them in memory so that it knows where they are, and then I've called count primes on the number 10, right? So if we look here, when we call a function, it creates a little space for that function and a spot for the variables that live just in that function. So you can see here that n is 10, right? And so now it's creating another variable, that count of primes variable, right? You can kind of see with these arrows, this arrow just ran, and this arrow is the next line that's about to execute. So we're going to execute line 9 for current number in range 2 to n. Remember, n is 10, so current number is 2. We start with 2, right? And then we're going to call isPrime on 2. Now this is what happens when we call isPrime. The countPrimes function is still running. It's just waiting for the isPrime function to get done before it can continue on, right? So we go into isPrime with n declared as 2, and then we're going to try to loop over a range of 2 to 2, but because there's no numbers between 2 and 2, it's just going to return true. And that's fine because we know 2 is a prime number. Okay, so then we're going to return true, which means if true is what happened right there. So since this if statement evaluated true, we got to say count of primes plus equals 1. So then we'll go to the beginning of the loop again, and we'll increment current number to 3. You can see how that happened here. Count of primes incremented, but it doesn't, again, increment until after we go through the if is prime check. So since our current number is 3, that means that current number here is 3, so we passed in current number here. Now if we click forward, isPrime is, it checks to see is 3 divisible by 2, and it isn't, so it'll go ahead and return 2. So we can kind of see every run of the isPrime function go through, right? 4 was divisible by 2, and so it returned false, right? And now 5 is not divisible by anything, and so it returned true. So you can kind of watch those functions run, true, true, false, and it looks like it's appearing that our code is doing the same thing that our steps that we wrote out before were doing. So that means we're doing good. We wrote code that does what we think so far. So the isPrime function happened with 7, and then it returned true. We're going to step through 8. It looks like our current number is 2. 8's divisible by 2, and so it's going to return false. So we know our isPrime function is doing what we think, right? Our count of primes has been increasing, and we know that there are 4 prime numbers under 10. We know 8's not a prime number, so we'll watch that turn into not a prime number and not get counted. We know 9's not a prime number, so we're going to watch that count of primes not get incremented, right? And then there we go, okay? And then what we're going to do is we're going to return the count of primes. One thing that I did note in our code, though the number is correct, the returned value is correct, I did notice that though we passed in 10, We never actually called it on 10. Now, when I did it in my walkthrough, I evaluated 10. But if you think back to what was the actual prompt, it said, find the number of prime numbers less than n. And so our solution is actually correct, even though I wasn't doing the steps exactly right. And so this is one of those things that if you're in an interview, you want to make sure to shake out that detail so that, when you get here, do I need to do less than n, or do I need to do n plus 1? What am I doing here? But you can see, it takes about 84 steps, right? So let's go ahead and edit this code, and let's just put it up to 20. Now, something that's really nice for us to just take notice of, to tell, how efficient is our code, and also how will our code change over time, is to put it in PythonTutor, right? Call it for one small n and then double n and see what happens. Now there's 260 steps, right? So 260 divided by 2 is 130, which means it's more than doubled. So what if I, double it again? Let's go to 40. Now there's 644 steps, right? So it's more than tripled. And so what we know is that our algorithm, as n gets bigger, is growing faster than n. And that's something that we can just notice based on the number of steps here. So this is how we can do things like evaluate our algorithms. We'll get deeper into what that really means and how do we talk about it. This is starting to get into big O notation, but this is something that we want to just take note of as we're solving our problems.